Our next topic of study here is motion in the sky. First thing we're going to talk about is just you look up and you see. So you go out at night, you look up and you see stars, but if you go out and look a little bit later, you see different stars. So what's going on here? Well, obviously it's Earth that's turning. And so as Earth turns, as you look up, you're going to see different things in the sky. And we call that diurnal motion. So diurnal motion is the term used for this daily rising and setting due to just looking up. Well, stars, as Earth turns, then it looks like the sky is moving by. In fact, the terms we use, sunrise, sunset, star rise, star set. Well, really, the stars aren't rising and setting. The sun's not rising and setting. Earth is turning, making that happen. So as things rise, what happens is, if you're on the equator, you see the celestial equator overhead, north celestial pole here, south celestial pole there. You see the entire sky go by. If you're standing on the north pole of the Earth and you look up, then the north celestial pole is overhead. As the sky turns, everything goes around, but everything in the southern half of the sky is below the horizon, and you can't see it from that location. Okay, now if you're, like, for example, in Fort Worth or someplace, you look overhead. Now overhead's 32 or 33 degrees above so the zenith is 32 or 33 degrees above the celestial equator, and so that means let's just say 33 degrees. Okay, so it's 33 degrees north of the celestial equator, or let's say 32. So if it's 32 degrees above the north celestial equator, that means the celestial equator is 32 degrees here. Now, 90 degrees is your horizon. So that means that you can see things down to 90 minus 32 degrees. So that's going to be 58 degrees below the celestial equator. Anything further south than that is below the horizon. Well, that's at its highest. As it goes around, it gets even lower. So at some point, you'll never see anything there. Now, this graphic here is actually for someone set, at 35 degrees north. And so they see 35 degrees north. They cannot see anything below 35 degrees south. But here, the North Star is here, which means you can see another 35 degrees on that side. Again, this is observer at 35 degrees north in this diagram. So I borrowed it from online somewhere, and so it's for someone in middle part of the country. Okay, but they would see the North Star, which is right near the North Celestial Pole, about 35 degrees up. Okay, but they would see some stars here that make loops around it that never set. Stars that never set are called circumpolar stars. Now, likewise, there's stars down here that never rise. Those also are circumpolar stars. So these would be the circumpolar stars that are always up, and these are the circumpolar stars that are never up. Okay. Now, depending on where you are on Earth, different stars are circumpolar. If you're standing at the North Pole, then exactly half the sky is always up and about half the sky is always set. If you're on the Earth's equator, nothing is circumpolar. You see the entire sky rising and setting. Okay. This is a time-lapse photograph facing towards the north. And so this is over the course of a night, and as the Earth rotates, the stars make these trails across the sky, and they go around the North Celestial Pole. There is a star very, very close to the North Celestial Pole that we call the North Star, or Polaris is the name of it. And so that star is special because it is always at very close to the same spot in the sky. It's a fraction of a degree from the North Celestial Pole, so that means it's always a fraction of a degree from due north. If you can find that, that tells you within less than a degree which way is north. And so that makes it a very useful navigation star. Now, to find the North Star, when I was a kid, in the Boy Scouts, they said find the Big Dipper. And then those two stars at the end of the Big Dipper point up there to this little star right there. That's the North Star. So this is the Little Dipper right here. Now notice the Little Dipper is normally very, very dim, and so most people in the city never see the Little Dipper because you can sometimes see that star, and occasionally that star, and the rest of these are so dim they're washed out by the light pollution. So that star right there, Polaris, there's the North Star. So that's diurnal motion. There's another kind of motion in the sky that comes about because Earth is also going around the sun, and that is what we call annual motion. And so the annual motion will be the topic of our next little mini lecture.